In a browser, go to molview.org, molview.org. So let's go to that website. So I'm going to close this. So here you can build a molecule and visualize the 3D version of it. So I'm going to erase this. So let's go to the delete and let's erase the molecule that we had. Okay, so let's build a molecule. Suppose you want to draw CH4, the methane molecule. So here, come to the carbon, put your carbon there. I'm going to zoom in a little bit and then add bonds to it. So I go to the bond tool, single bond tool, then add a single bond on carbon. Okay, notice the carbon disappears because in chemistry we don't explicitly show the carbons, so but each corner there is a carbon. So I'm going to touch at one corner again, so it added another bond to the carbon. So here's another bond on the carbon, here's another bond on the carbon, and then I'm going to add hydrogens to the end. So touch the hydrogen there, and you want to wait until the end of the bond highlights and then click on it. Okay, here's your CH4. Remember the center, even though it's not showing there, it's a carbon. Now you can transfer this to the 3D. So click the 2D to 3D on the top, and there you go. So now we have a 3D view of your methane molecule. Notice that it's no longer flat. It's a tetrahedral molecule. The shape of the molecule is tetrahedral. Now, how do you measure the length of the molecule? So length is the longest dimension. So let's try to measure the distance between any two hydrogens. So if you go to JMOL, you can measure the distance, you can measure the angle. So let's measure the distance. So select distance, and all you have to do is click the two atoms that you want to measure the distance between. Okay, so ignore these messages. I'm going to ignore them. So let me make sure. Yes, I've selected distance. So I'm going to click on two atoms. And then there we go. We get the bond distance. So remember, this program gives you the distance in nanometers, and you want to convert that to angstroms. A nanometer is 10 to the negative 9 meters, but an angstrom is 10 to the negative 10. So angstrom is smaller, that means by unit of 10. So that means your number should be bigger. So you have to multiply these numbers by 10 to convert them to angstroms. So the distance between two hydrogens is 1.78 angstroms. Will it fit in the clathrate pore? Your lab manual asks you, will it fit? So please read the instructions before the table. It's going to tell you the pore size of the clathrate, and you want to compare the length of the molecule with the pore size and decide whether your molecule fits into that clathrate or not. To measure a bond angle, so go to JMOL angle. Now you have to touch three atoms to measure the bond angle between them. So hydrogen, carbon, hydrogen. Let me do that again. Hydrogen, so clean. So go to angle, hydrogen, carbon, hydrogen. There we go. We measured the bond distance, bond angle, and it's 109.5 degrees. So methane molecule is going to have equivalent bond angles. All the bond angles here in this tetrahedron are 109.5.